Hello and welcome dear learners to the NPTEL course on Healthcare Quality Management, Infection Control and Patient Safety. In the Module 5, Operational Excellence in Healthcare, in continuation with Chapter 51, Strategic Planning for Patient Safety Part 3, we will be dealing with patient rooms, special patient care rooms and building engineering systems. So what are the patient rooms discussion to be taken ahead for? So single occupancy rooms, as we see, are known to reduce the incidence of infection compared to multiple occupancy rooms that share common infection exposure sources. And there we find most of the patients, they always emphasize that you need to take them for single occupancy. The reason is like multiple occupancy rooms are mandated and it is important to maintain a minimum clearance of at least 1.2 meters between two beds, where the risk in the multiple occupancy rooms is more with respect to the infection. Access and circulation, where you find access to patient rooms should be through a clear 1.2 meter wide movement path, where with respect to the patient's relatives and the healthcare providers, they need to get an access and a circulation with dealing with the patient. This pathway should allow movement of transfer equipment and bed to trolley and vice versa, which reduces the risk of injury of the patient. Clear bed space and furniture. The access space to the bed should be free of any incursion for furniture and fixtures. So all the furnitures and fixtures must be checked for height adjustability to enable patient mounting and dismounting conveniently, and which makes a patient more space actually to deal with its own issue and the healthcare workers actually for the healthcare interventions. Communication and emergency response. So patient rooms should be equipped with two-way communication, especially with communication linked to the nurse, who are to be identified as the first line communicator actually to the patient. Nurse call system should be well planned and escalated as required because they are the one to be called up for the first level of emergency. Response times can be long without proper system, creating impetus for prompt patient attendance and to infringe actually if there is a provision of code blue in patients which allows immediate activation of the medical staff system in case of emergency to be given as. Your staff need to be well alert and need to be skilled up actually for the support of cold blue installation. Sanitation and toilet access. The nurse call system should extend into patient toilet as well, and the toilet door should open outwards to ensure access in case of patient collapse or patient gets major injury into the toilet. Toilet should be equipped with termed panic call, which functions as an extension of the nurse call system where the patient sometimes is being identified to get panic into the toilets. What this allows the nurse station to be accessed from within the toilet during emergencies, and seating on the toilet must allow easy assisted transfers, and where it is very important actually to deal the patient's issues if it come across into the toilet. Toilet flooring should be anti-skid to avoid slippy and falling issues actually, because slipping and falling issues are more into when you find that the slopes are very slippery, which gives major patient safety issues. With respect to lighting and patient comfort in the room, the normal schedule of natural light is important for a psychological well-being of a patient to get easily recovery. Windows must meet fire safety and building code requirements. Blinds and shade should block natural light sufficiently to prevent glare and discomfort to the patient. Artificial lighting should provide task lighting for patient care and night lamps for the orientation. Provision of two-way switching for light allows patient control and comfort. So you can understand over here the importance of lighting and patient comfort is directly linked up. Privacy and hand hygiene. When you deal with a patient, the healthcare worker need to understand the privacy curtain should suspend from ceiling and not from false ceilings. Ceiling mounted curtain track prevent collapse in case of ceiling falls, which is very important that major of those issues comes with the curtains, whereby operable windows are provided with grills should be installed to prevent the fall and the risk can be mitigated easily. Insect screens must be provided and hand wash station should be located within the patient room to enable hand hygiene before and after patient contact, which reduces the risk of HAIs. With respect to spatial patient care room, what are the important things we need to understand? Protective infection isolation, which comes with a condition to check and control airborne infection, which apply to both protective isolation and infectious isolation. One thing which we need to understand for isolation, it is that it is very critical care units and must be extended to inpatient units in designated numbers. So, patients who require isolation but not critical care must be still from accommodated safety. So, you need to work on the protective part versus to an infection isolation with that is more for infectious patients. What is a combined isolation? So, combined isolation is intended for patients who are immunocompromised, patients who suffer from airborne infection, and in such rooms which must be equipped with anteroom and high relative pressure. So, these features reduce the transmission risk and protective vulnerable patient, which is very important to understand the importance of combined isolation over here. What are now to be taken as psychiatric consideration when designing the special patient care room? Rooms for psychiatric patient must be designed to facilitate monitoring and prevent escape or injury. Where you find that this is very important for a hospital to understand psychiatric need considerations, if not taken, can lead to major problem with respect to special room where the patients such as psychiatric patients are identified majorly to escape actually. What is the bariatric patient room? Bariatric patient room must have minimum clear floor area of 18.58 square meters, that is 200 square feet. The hospital variance acknowledges the need to support patients weighing over 500 kg, and these are the patients actually which take lot of efforts for the hospital to deal with lot of staff, where space is very important to take such patients, and India is nowadays getting lot of patients actually in medical tourism with respect to surgeries which are more bariatric surgeries. Shower spaces must be designed to support 500 kg loads, and with respect to injury to the patient, you need to design the toilet which should have at least 1.2 meter multiplied by 1.8 meter and equipped with grab bars actually to hold the patient as well as the patient can get support. Design must account for a load of 500 kg consistently, which is very important when you design such a bariatric patient rooms. Now, building engineering system, and what are those? When you have a structural design consideration, you need to understand these are granted but is critical in healthcare facilities. Hospitals require deployment of heavy equipment such as X-rays, CT scanner, MRI, catheterization labs, linear accelerators and PET scan. These loads are not uniformly distributed and may exceed 500 kg. Structural slabs and foundation must be reinforced accordingly. What is bariatric load consideration? When we talk about the facilities which need to take the support of loads 500 kg per patient, and the structural evaluation must consider load transfer, deflection and vibration. So use of flat slab designs may discourage heavy roll accommodation. Increased flow-to-flow heights may be required to root out the engineering services. And with respect to HVAC, which is to be regulated indoor air care quality, temperature and humidity, and if you identify that a poor HVAC design which leads to communication breakdown and adverse patient outcome are an issue which are to be seriously taken for HVAC. Inadequate ventilation can rapidly deteriorate the indoor condition, and you may find that many healthcare spaces require high air chance rate of HEPA filter, where the HVAC must support dilution of contaminants and maintenance of natural ventilation where it is possible. So air conditioning units such as splits or windows may not suffice for the clinical areas, and this you need to work in the planning stage for these departments. Standards and compliance. As uttered in the previous chapter, HSRE 170/2008 is the accepted standard for healthcare ventilation. You need to work on the HVAC system which needs to be designed for appropriate air handling, unit sizing and corrective air changes rates and pressure gradients. Now, with respect to monitoring and pressure control, compliance with the temperature, humidity and pressure gradients must be monitored continuously. Monitoring system may include flutter strips, airflow meters and differential manometers. Pressure gradients must be maintained at all times to prevent cross-contamination. Operating room require constant pressure maintenance. Shutdown of HVAC system for maintenance requires validation before use when they have to be started for. Now, with respect to plumbing system, what are the issues? Water flow systems which requires more to be used in domestic water supply, hot water system, steam generators and drainage. So water treatment system must be tested periodically and it is to be made as a norm. Static water storage should be avoided as it promotes microbial growth. And wherever unavoidable water stagnation risk must be mitigated, and this assures you that your plumbing system has made a proper work. Now for reverse osmosis and water treatment. Like reverse osmosis plant must meet standards prescribed by the Association for the Advanced of Medical Instrumentation, that is ME and EN standards. These standards are stringent and essential for patient safety and which will reduce maximum issues which will occur for the patient safety. Now, with respect to drainage and wastewater. Drainage from the radioactive toilets and hot labs must be routinely carefully taken off. Such effluent must not enter the sewage treatment plant directly. Once the biochemical oxygen demand BOD and the chemical oxygen demand COD are within the acceptable limits, water may be reused for flushing, HVAC makeup water and irrigation, which is a need that you need to work on the sustainability part of the water, where you may find the recommended values versus the recommended COD level and the primary rationale for taking. As you know, the sanitary flushing, HVAC makeup and irrigation, which are one to see the norms to be taken ahead and which makes your drainage system and wastewater to be more usable for the hospital purposes. Now, for the power systems, what is the load estimation and inrush current? So, when you talk about connected versus demand load, this is typically a significant difference between the connected load and the actual demand load in the healthcare system. X-ray inrush currents, where imaging equipments, notably X-ray machines, creates monetary high inrush currents that skew load patterns. And system sizing consideration. Inrush currents must be considered when sizing feeders and distribution equipments. For systems more than 750 kW, the momentary nature of the X-ray operation generally does not majorly add to the overall utility power demand. Where the risk of miscalculation, where overestimation causes avoidable cost while underestimation risks tripling critical applications during the use of this. Now for the critical power continuity and infrastructure. You need to have a mandatory backup, you need to work on the flood protection and you need to impact for the power loss. Reason for taking mandatory backup is for the provision of standby and backup power is maintained for all critically healthcare loads. For flood protection, power plant, substations, panel and DG setups must be located above the flood level where you can tackle it more easily. Impact of power loss. When you find with respect to surgery procedure or medical laboratory work actually which can come down or stand still if the power loss is there. Blood bank refrigerator, which is a very risky for losing vital supplies actually if the power get lost. Autoclave cycles may be aborted or require tests to be redone actually, which is more on emphasizing the resources or sometimes making it more standstill. With respect to patient safety and circuit protection, how the patients are to be found vulnerable actually when they are highly susceptible to electrical shock due to weakened conditions, anesthesia or an unconscious state, shocked, non-fatal to healthy patients can be fatal to patients. So you may find patients are extremely vulnerable with respect to this. Life support equipments, devices like heart pumps, dialysis machines and ventilator require continuous power. Circuit breakage usage. Standard earth leakage circuit breakers are not recommended for critical patient application because they trip power during the overloads. And UPS role. Uninterruptible power supplies. UPS provides clean, uninterrupted power for life support system, and which is very important that you need to have a UPS role to be identified over here as. Now, specialized medical electrical hardware. It comes as medical grade isolation transformer which are recommended for operating rooms and ICUs, equipped with monitoring panels for insulation and earth leakage status. Must emit an alarm on the occurrence of the first fault. Hospital grade receptacles must meet specific UL, that is Underwriter Laboratories criteria for grounding path integrity and medical strength. The isolated ground receptacles recommend for microprocessor based equipment to protect against electrical noise. Tamper proof receptacles mandated for pediatric and psychiatric ward, and dedicated receptacles for X-ray applications which require dedicated non-interchangeable receptacles to prevent drawing power from circuit not designed for the load. Now, in this particular figure, you can see the critical versus non-critical loads and circuits, where you can find the life support equipments on continuous power and non-critical loads on the trippable circuits. So, the emphasis of circuit is very important over here, where non-critical load, where these are used for the patients but are not directly leading for care part, where versus the equipments over here on this side is shown that which are very important for the patient care. So, critical load where UPS supported, and you may find that the life support equipments are continuous power and non-critical loads are on the triple able circuits, where you may find in power loss actually this can deal, but these are the instruments you cannot deal up when the power supply is completely lost. Now, in the figure 2, you may find the specialized hospital grade hardware, and on the other side where the normal and the fault part is shown, actually the medical grade isolation transfer or panels that indicate the status of insulation and earth leakages. These emit an alarm on the occurrence of the first fault, and the healthcare worker can identify and can raise a concern actually to deal with this issue. Safety identification and installation. Routine way, if you have to deal the restrictions actually for this part, you need to understand that oxygen and electrical terminations must not be routed in a wooden panel to avoid a trade of hazards. Power source distinction. It is critical to distinguish between a raw power and a emergency power. With respect to normal and here emergency power, which is shown in red, where the normal power which is indicated over in white actually, where the labeling is very important. Labeling is a standard practice and it needs to be encouraged. Color coding is one which is deploying the power receptacles of different color and which is considered a foolproof method of safety and ensuring the safety with respect to the power sources, and healthcare worker also need to be given a training for this part. Now, this figure is giving you a clarity on electrical power system in healthcare facilities, safety and reliability. The first part, which is the power source and load estimation, which is being seen, that load estimation, power backup, that is DG sets and UPS, and connected loads, that is with respect to demand load. Hey, here the power distribution for critical versus non-critical, where non-critical loads, that is bedside lamp, general lighting and standard circuit breakages, wherein the critical load is more towards the ventilator, heart pump and dialysis, and uninterruptible power supply, which is like provides clean continuous power, loss to be, and if it is lost can lead to a fatal issues. So, no earth leakages, circuits breakages actually over there, where you can see the patient care areas, receptacles and safety interfaces which we have discussed with respect to operating rooms, what it needs to have, insulation and earth leakages monitor, and sensitive equipment areas and specialized wards over versus to power distribution, where the labeling and the color codings are to be emphasized. Specialized wards such as pediatric and psychiatric ward need to have tamper proof receptacles, where an X-ray application should have dedicated receptacle which is to be installed over here. So in the summary to this chapter, actually I want to emphasize more that the patient rooms must prioritize infection prevention, safe movement, clear bed access, effective communication system and adequate lighting. Privacy and safe toilet design to support the patient comfort and emergency response. With respect to special care rooms, isolation, pediatric and psychiatric room requires enhanced spatial planning, emphasis on pressure control, load bearing capacity and safety features to protect the vulnerable patients and the caregivers as well. With respect to structural design, we have discussed in this chapter, which emphasize most on accommodating the heavy medical equipment and bariatric loads, ensuring the reinforced slabs, adequate floor heights and long-term structural safety. For HVAC system, which is identified to play a critical role in infection control by maintaining air quality, pressure gradients, filtration standards and continuous monitoring as per the healthcare ventilation norms. Plumbing and power systems are also discussed with respect to control the microbial growth and ensuring the safety with respect to radioactive and biomedical influence. From the power system plant, it is very important, which is to be identified as a central to the patient safety, requiring redundancy, uninterrupted flow for the critical areas where it cannot be seen, that you cannot come across actually if there is a power stop. Proper grounding, clear segregation of emergency and normal power is very important to be seen as well labeled and hospital grade electrical infrastructure. So with this we come an end to this chapter and you can take these references for your work. So thank you for patience listening.